Hello friends, here in this video we are going to see what is meant by diesel cycle. This is the third cycle in case of air standard cycles. Now diesel cycle, see diesel cycle, it is a theoretical cycle which is used for diesel engines. I'll write it down that it is a theoretical cycle used for compression, ignition, or we can say compression ignition are also called as diesel engines. So here it is a theoretical cycle used for compression ignition or diesel engines. Next point, in this cycle the heat addition process takes place at constant pressure. Hence, this cycle is also called as constant pressure cycle. So here, as I have written that in case of diesel cycle, the heat addition process takes place at constant pressure, so it is also called as a constant pressure cycle. Next, I'll write down the processes which take place in diesel cycle. So the following processes take place in diesel cycle. Now what are the processes? First, process 1 to 2, it is reversible adiabatic, which is also called as isentropic compression, the first process. Next, process 2 to 3, it is constant pressure heat addition. Then process 3 to 4, it is reversible adiabatic, or we can say isentropic expansion. And the last process is, after expansion we have process 4 to 1 as constant volume heat rejection. So now, as we have seen here, there are 4 processes in case of diesel cycle. The first one, process 1 to 2, is reversible adiabatic, also called as isentropic compression. Entropy remains constant here. Process 2 to 3 is constant pressure heat addition. Process 3 to 4, reversible adiabatic, that is isentropic expansion. And process 4 to 1, constant volume heat rejection. Now these are the 4 processes. Next, I'll show all these 4 processes on PV and TS diagram for the diesel cycle. So here we have PV, that is pressure and volume, and TS, that is temperature entropy diagram for diesel engines, or we can say it is for diesel cycle, one and the same thing. Now I'll draw the diagram. This PV and TS diagram is nothing but a graph, that is PV diagram is a graph between pressure and volume. TS diagram is the graph between temperature and entropy, and this I can say that it is also called as diesel cycle. Now, when I am plotting the graph, since the first process, as we know, process 1 to 2 is reversible adiabatic, that is isentropic compression. So, isentropic compression will be shown on PV diagram by a curve starting at 1, ending at second. So, here this process 1 to 2 indicates adiabatic, reversible adiabatic or isentropic compression, wherein we can see that volume at point number 1, V1 is more. So, after compressing, after the compression takes place, the volume decreases. That is from V1 we reach up till V2, and pressure rises. So, that is compression process, that is in which the volume will go on decreasing but pressure will go on increasing. So, as we can see here, the pressure at point number 1, that is P1, it is less compared to the pressure at point number 2, that is P2. Now, after understanding the first process, the second process is 2 to 3 constant pressure heat addition. So, now heat will be added after point number 2, heat will be added at constant pressure, that is from 2 to 3. Here I can say that pressure at point number 2 and 3 they are same. So, P2 will be equal to P3. Next, after the constant pressure heat addition, we are increasing the volume from 2 to 3, that is V2, and now the volume will be V3. Next, process 3 to 4 is reversible adiabatic, that is isentropic expansion. So, after the compression and heat addition process, there is expansion, and it will be a curve as it was for compression. Similarly, we will have a curve for expansion as well, that is we reach at point number 4. So, when the expansion process takes place, as we can see here, the volume at point 3 it was less. Now the volume at point number 4, that is V1 is equal to V4, it is greater. So, we can say that from 3 to 4 expansion has taken place, that is volume has increased but pressure has dropped. Next, for process 4 to 1, here it is given that process 4 to 1 is constant volume heat rejection. So, heat will be rejected keeping the volume constant, and pressure will drop along this process. So, here is the diesel cycle on PV diagram. Next, this diesel cycle I will even denote it onto the TS diagram, temperature entropy, as the first process is isentropic process or isentropic compression. So, isentropic compression will be shown on TS diagram with a vertical line point 1 to 2. Now, as we can see, in case of isentropic compression, the pressure has increased, and even in case of compression the temperature also increases. So, temperature increases from point 1 to point 2. So, now your process 1 to 2 indicates isentropic compression wherein temperature has increased. Next, 2 to 3 is constant pressure heat addition. So, here what I will do, I will draw a light line representing. Now, this line is a constant pressure line, P is equal to constant. Now, I have to add heat along 2 to 3 because it is heat addition process, and that should be at constant pressure, means I should move along this constant pressure line by increasing the temperature from point 2 to point 3. So, I will go on increasing the temperature from 2 to 3. So, as we can see here on TS diagram, here I have shown 2 to 3 as the heat addition process wherein temperature increases keeping the pressure constant. So, it is clear that since it is a constant pressure line, it will have a single pressure value, and pressure at point 2 and point 3 both will be same corresponding to the pressure here. Next, process 3 to 4 is isentropic expansion wherein the entropy remains constant and temperature drops. So, here I have from process 3 to 4, this is a constant entropy process wherein entropy of point number 3 and entropy of point number 4 are same as it was same for point 1 and 2, because it was an isentropic process. Entropy remains constant. Now 3 to 4 indicates isentropic expansion, the temperature has dropped, and as we can see from the PV diagram, during 3 to 4 the volume increases and pressure drops on PV diagram. In case of TS diagram, entropy remains constant and temperature drops. So we can say that during the expansion process both temperature and pressure they drop, but entropy remains constant and volume increases. Next, process 4 to 1 is constant volume heat rejection. Now that constant volume heat rejection, again here I'll draw a line passing from point 1 to point 4. Now this will be called as the constant volume line. On this constant volume line, I'll show the heat rejection process wherein temperature drops and even the entropy decreases here. So 4 to 1 indicates the heat rejection process wherein we are getting the drop in temperature along with the drop in entropy, keeping the volume constant. Now I'll mark the values here. From 1 to 2 it is called as isentropic compression, so work is input to the system during compression, so that becomes W suffix C. Next, for process 2 to 3 heat is added into the system, so here this is the heat addition process. Then from 3 to 4 heat we are getting expansion, the work is produced from 3 to 4, so we are getting work output from the engine, so that is work which we are getting from expansion process. Next, from 4 to 1 there is heat rejection process. After the work has been produced from 3 to 4, then it will be a heat rejection process, that is at constant volume. So here I have Q suffix R as a heat rejection process. Similarly, I can show all these values on TS diagram as well. Process 1 to 2 is isentropic compression, so it is input to the system. Then 2 to 3 is constant pressure heat addition, Q suffix A. 3 to 4 is isentropic expansion, which is W suffix E, the work we are getting in case of expansion process. Next, 4 to 1 is the heat rejection process, which we are getting it as the heat rejected or heat going out from the system. So now here I have marked all the points in case of PV and TS diagram. Related to that, I'll write some points that at point number 1, at point 1, only air is taken into the cylinder, or we can say engine. So at point 1 the air is taken into the cylinder or engine. Then from process 1 to 2 we can say that after air has entered the engine, it is compressed isentropically, that is keeping the entropy constant. S1 is equal to S2, keeping the entropy constant. Next, I'll write down during the compression process, volume of air decreases, but there is an increase in pressure and temperature of the air. So, as we have understood that after the air has entered the engine at point number 1, there is reversible adiabatic, or we can say isentropic compression. In this compression process, there is decrease in volume from V1 to V2, an increase in pressure from P1 to P2, and similarly there is an increase in temperature from T1 to T2. So this completes the compression process. Next, once we have reached the compression process, at point number 2 the fuel injection starts. That is, here it is diesel engine, so diesel would be injected. Next, at point 2 the fuel injection, and here we have diesel as the fuel. So fuel injection starts and fuel is added at constant pressure up to point 3. So process 2 to 3 is constant pressure heat addition. So as we can see that from process 2 to 3 the heat has been added at constant pressure and there is an increase in temperature from point T2 up to point T3. Next, once the heat addition has been completed up to point 3, then from point 3 the expansion process, the expansion of air, I can say, because since it is air standard cycle we are assuming there is more part of air, less part of fuel, so it is basically an air standard cycle having air as the main working fluid. So at point 3 the expansion of air takes place, which pushes the piston and we get mechanical work output from the engine. So now here I have written that from point 3 the expansion of air takes place, which pushes the piston and we get mechanical work output from the engine. Hence I'll say that process 3 to 4 is called as reversible adiabatic or isentropic expansion process. Now process 3 to 4 indicates the reversible adiabatic or isentropic process as I have shown it on PV and TS diagram. Next, after the expansion of air and we get mechanical work, the heat which is there inside the engine must be rejected. So once we have attained the work from the engine, that is the expansion of air has taken place, it has pushed the piston down and we are getting the mechanical work. Now the heat which is there inside the engine must be rejected to the atmosphere, and so I can say that heat rejection starts at point 4 after expansion and it, that is heat, gets rejected at constant volume from point 4 to 1. That is, as we can see from the diagram, once we have attained the work from 3 to 4, from point number 4 the heat rejection starts and it is rejected from 4 to 1, keeping the volume constant. As we can see, V1 is equal to V4, and the same thing we have denoted it on the TS diagram, which is from 4 to 1 there is heat rejected out of the system. So I'll write down, in this way the diesel cycle gets completed. And next, once we have completed the diesel cycle, then I can write the formula of efficiency of diesel cycle, and that formula is, I'll write down, therefore efficiency of diesel cycle is given by efficiency of diesel, that is equal to 1 minus 1 upon R suffix C raised to gamma minus 1 into bracket rho raised to gamma minus 1 upon gamma into rho minus 1. So here I have written the formula of efficiency of diesel cycle, that is with the help of this formula we can calculate the efficiency from a diesel cycle, and we can compare actual diesel engine with the theoretical efficiency of the diesel engine we are getting here, and from that we can make out if the claim is true for the diesel engine or false. Here I'll denote the terms, that where R suffix C is called as compression ratio, and that compression ratio is volume before compression, that is we can say cylinder volume, upon volume after compression, that is clearance volume. So therefore R suffix C is equal to, I can show it on the diagram, that volume before compression was up to V1, which is the cylinder volume. Volume after compression is V2, called as the clearance volume. So V1 by V2 is RC, and this value will be, it will be always greater than 1, a positive value, and greater than 1. Next, rho, or first I'll denote gamma, it is called as adiabatic index, having a value of 1.4. Then rho, it is called as fuel cutoff ratio, which is fuel cutoff ratio is volume after cutoff to the volume before cutoff. And as we can see, this cutoff is nothing but the cutoff of fuel supply. So volume after the fuel has been cut off, fuel injection starts from point 2, it ends at point 3. So volume after cutoff, here at point 3 there is cutoff of fuel, fuel is stopped. So at this point the volume is V3, so volume after cutoff is V3, and then volume before cutoff, fuel has been started injected at point number 2, here the volume is V2. So V3 by V2 is nothing but fuel cutoff ratio, and gamma, as I have written, adiabatic index, and for isentropic process the value is 1.4. So with the help of all these terms, that is RC, compression ratio, fuel cutoff ratio, and adiabatic index, we can get the efficiency of diesel cycle, which is a theoretical efficiency, and from that we can compare it with the actual diesel engine. So in this video we have seen the explanation of diesel cycle along with its processes, PV and TS diagram, including the efficiency of diesel cycle.